Hi there, my name is Bailey, and before I start my presentation on the brainstem respiratory centers, I kind of wanted to explain why you're staring at some succulents at the moment. I wanted to primarily focus on the roots of these succulents, how you can kind of see them stemming down, which is primarily what we're talking about, the brainstem respiratory center. We want to talk about the actual stems. So the actual succulent itself is just a byproduct of those stems. So view these visually as a easier way to remember them. That's kind of how I perceive it. But don't forget that this is what we're primarily talking about. So you're seeing this, we're talking about this. The automatic unconscious cycle of breathing is controlled by three parts of respiratory centers in the reticular formation of the medulla oblongata and the pons. The medullary rhythmicity center is found in the medulla oblongata and has two groups. So we're effectively talking about this as the medullary rhythmicity center. Starting over here is the ventral respiratory group, or the VRG. It sets the rhythm of breathing, how often you are inhaling, and is the primary generator of the respiratory system. It is an elongated muscle in the medulla with two commingled webs of neurons, the inspiratory neurons and the expiratory neurons. Each form a reverberating neural circuit. The inspiratory neuron circuit fires about every 2 seconds, issuing nerve signals to integrating centers in the spinal cord. This output travels to the external intercostal muscles. These are several groups of muscles that run between the ribs and help form your chest wall, which tells these muscles to contract, which enlarges the thoracic cavity and causes inspiration. These neurons eventually will stop firing from fatigue or from an outside source. As long as the inspiration neurons are firing, they inhibit the expiratory neurons. Expiration neurons start up, further inhibiting the inspiration neurons and allowing the inspiration muscles to relax. This process causes the thoracic cage to recoil, causing air to be released from the lungs. Once the expiration neurons stop firing, the inspiratory neurons begin, and this is a cycle. So in quiet breathing, the alteration between these two neurons produces a respiratory rhythm of about 12 breaths per minute. Next, we're going to talk about the dorsal respiratory group, or the DRG. It works on inspiration in that it modifies the rate to adapt to varying conditions. We know that there are many varieties to breathing: fast, slow, shallow, because the ventral respiratory group is subject to so many influences, and the dorsal respiratory system group is the primary reason. It is also a group of neurons that extends much of the length of the medulla between the ventral respiratory group and the central canal of the brainstem. It is an integrating center that receives input from a variety of sources. In this example, I'm going to be talking about 4. Here is the first one. It is the central chemoreceptors in the brain. They're brainstem neurons that respond to changes in the pH of the cerebrospinal fluid. The primary job of the central chemoreceptors is to maintain a stable pH. The respiratory centers also ensure a stable blood carbon dioxide level. The second is the peripheral chemoreceptors that are located in the carotid and aortic bodies of the large arteries above the heart. They respond to oxygen and carbon dioxide content of the blood, but most of all the pH levels. They communicate with the brainstem by way of glossopharyngeal nerves and the aortic bodies by way of the vagus nerves. The third are the stretch receptors, and they are found in the smooth muscle of the bronchial and bronchioles and in the visceral pleura. They respond to the inflation of lungs and signal the dorsal respiratory group by way of the vagus nerves. When the lungs are excessively inflamed, it causes the Herring-Brewer reflex, which is a perfect protective somatic reflex that strongly inhibits the inspiration neurons and stops inspiration. The last are irritant receptors. They are nerve endings amid the epithelial cells of the airway, and they respond to smoke, dust, pollen, chemicals, fuels, cold air, things of the like. They transmit signals by way of the vagus nerves to the dorsal respiratory group, much like the peripheral chemoreceptors and the stretch receptors. The dorsal respiratory group returns signals to the respiratory and bronchial muscles, resulting a protective reflex such as the bronchial constriction, shallow breathing, and breath holding, and commonly coughing. Simply put, through these receptors, the dorsal respiratory group issues output to the ventral respiratory group that modifies the respiratory rhythm to adapt to varying conditions. So lastly, we're going to talk about this one is the pneumotaxic center, or the pontine respiratory group. It is found in the pons. It regulates the shift from inspiration to expiration in quiet breathing. This group receives input from the higher brain centers, including the hypothalamus, limbic system, and the cerebral cortex. It's output to both the dorsal respiratory group and the ventral respiratory group. By acting on the centers in the medulla, it hastens or delays the transition from inspiration to expiration, making each breath shallower or shorter, longer or deeper as needed. The pontine respiratory group adapts breathing to a variety of special circumstances such as sleep, exercise, and emotions such as crying, gasping, and laughing.